Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing numericals based on laws of chemical combination. Now I will discuss from the question number 264. Last class I discussed up to question number 263. Now I am going to discuss questions from 264 based on chemical equation. These numericals are little tough. Keep pen and paper with you. Now I am reading the question. Question number 264. The mass of calcium oxide that shall be obtained by heating 20 kg of 90% pure limestone is first 11.2 kg, second 8.4 kg, third 10.08 kg, fourth 16.8 kg. Limestone means calcium carbonate. Now one more time I am reading the question. The mass of calcium oxide that shall be obtained by heating 20 kg of 90% pure limestone is first 11.2 kg, second 8.4 kg, third 10.08 kg, fourth 16.8 kg. Just think. I think you are able to solve the numericals. Just to think. You have to calculate the mass of calcium oxide which you will get from the 20 kg of 90% pure limestone. Okay, in calcium carbonate other things may be also present as impurity. That's why it is a 90%. 10% may be impurity. Then from 20 kg, how much you will get calcium oxide, that you have to calculate. Now just to think. Here you should know, first you have to write the equation. Chemical equation means a decomposition of calcium carbonate. Then calcium carbonate, when it will be heated, it will decompose into calcium oxide plus carbon dioxide. Then calcium carbonate, its molecular mass is 100. Ca40 plus C12 plus 48. O3 means 48. 100. Then 100 gram will give 56 gram calcium oxide, CaO. Correct? Then on the same basis we can write 100 kg will give 56 kg. Same way. 100 gram is giving 56 gram. Then 100 kg means 56 kg. 100 kg will give 56 kg calcium oxide. Then pure limestone means calcium carbonate in 20 kg, because it is 90% pure. Then 90% of 20 means 18 kg. 20 kg pure limestone will give 18 kg. Correct? Because it is 90% pure. Then 90% of 20, 18 kg. Then 100 kg calcium carbonate give calcium 56 kg calcium oxide, 100 kg. Then 1 kg, then 18 kg. Correct? According to the equation, 100 kg calcium carbonate That gives 56 kg calcium oxide. Then for 1 kg, then for 18 kg. 18 kg calcium carbonate gives how much? Then 56 divided by 1000 into 18. Correct? 100 kg calcium carbonate gives 56 kg calcium oxide. Then for 1 kg, then for 18 kg. You will get 56 divided by 100 into 18. Upside 18. You will get 10.08 kg. Hence correct answer is option C, 10.08 kg. Next question I am reading. X gram of silver was X gram of silver was dissolved in HNO3 and the solution was treated with excess of NaCl. When 2.87 gram of AgCl was precipitated, the value of X is first option 1.08 gram, second option 2.16 gram, third option 2.70 gram, fourth option 1.62 gram. Again I am reading question one more time. X gram of silver was dissolved in HNO3 and the solution was treated with excess of NaCl. When 2.87 gram of AgCl was precipitated, the value of X is first option 1.08 gram, second option 2.16 gram, third option 2.70 gram, fourth option 1.62 gram. Just to think. You think in a correct way, only then you can solve the numericals. X gram of Ag, you have to find out value of X. Just to think. Here you should know silver is equivalent to silver nitrate. Correct? Because X gram silver was dissolved in HNO3. Then it will form AgNO3, silver nitrate. And due to this silver nitrate, you are getting silver chloride on reaction with NaCl. Correct? AgNO3 plus NaCl, you will get AgCl, silver chloride. Then Ag is equivalent to AgNO3 and AgNO3 is equivalent to AgCl. Correct? Because Ag is giving AgNO3 with reaction with HNO3 and silver nitrate plus NaCl, it is giving AgCl. Then all three are equivalent. Ag is equivalent to AgNO3, AgNO3 is equivalent to AgCl. Then Ag, its atomic mass is 108 gram. And silver nitrate, it is 143.5. Correct? Silver nitrate. Then Ag means 108 plus nitrogen 14 plus 48. You will get 143.5 gram. Then 143.5 gram AgCl. 143.5 gram AgCl is equivalent to 108 gram silver. Correct? Because silver nitrate and AgCl both are equivalent. Hence 143.5 gram silver nitrate is equivalent to 143.5 gram AgCl. Both will be equal because both are equivalent. Then 143.5 gram AgCl, that is equivalent to 108 gram silver. 143.5 gram AgCl you are getting from 108 gram silver. then for 1, then for 2.87. According to the question, you have to calculate, because it has given 2.87 gram of silver chloride. According to the question, you got 2.87 gram silver chloride. Then 143.5 gram AgCl you are getting from 108 gram silver, then for 1, then for 2.87 gram AgCl. Then 108 divided by 143.5 into 2.87. 2.87 is upside, correct? Then after solving, you will get 2.16 gram. 2.16 gram. Hence correct option is B. Value of X means value of silver was 2.16 gram. Okay, you have calculated. Option B is correct. Now next question. Question number 266. What mass of calcium chloride in grams would be enough to produce 14.35 gram of silver chloride? Atomic mass of silver chloride, you can calculate. Just now I told you. Okay, here you can calculate also that atomic mass of here in question actually it is given atomic mass of calcium is equal to 40 and silver is equal to 108. Easily you can calculate, you can say this mass of atomic mass of molecular mass of AgCl. Easily you can calculate. Again I am reading the question. What mass of calcium chloride in grams would be enough to produce 14.35 gram of silver chloride? First option 5.55 gram. Second 8.295 gram. Third 16.59 gram. Fourth 11.19 gram. Just to think, I think easily you can solve it. But you have to write the reaction. Only then you can solve it. You have to calculate mass of calcium chloride in gram. Correct? Just to think. Now I am giving you a hint. First you have to write the reaction. Calcium chloride plus silver nitrate. That reaction you have to write. Then it will give AgCl plus calcium nitrate. CaCl2 plus 2AgNO3. It will give 2AgCl plus CaNO3 whole 2. Then what is the actually molecular formula of calcium chloride? Calcium is equal to 40, 35.5, that is for Cl. Then for Cl2 71. Add all. 40 plus 71, you will get 111 gram. Then 111 gram on reaction with silver nitrate, it will give 2 into 143.5 gram AgCl. 2 AgCl it will give. In a balanced equation, you will find, you will get 2 AgCl. CaCl2 plus 2 AgNO3, you will get 2 AgCl plus CaNO3 whole 2. Then 111 gram, 111 gram gives 2 into 143.5 gram silver chloride. Then for 1, then for 14.3. Actually, you have to calculate amount of calcium chloride. Then 2 into 143.5 gram AgCl. You are getting from 111 point calcium chloride. 111 gram calcium chloride. Then for 1, then for 14.35 gram. You have to calculate. Then 2 into 143.5 gram AgCl. For that you require 111 gram calcium chloride. Then for 1 gram, then for 14.35 gram AgCl. Okay, you will get 111 divided by 2 into 143.5 into 14.35, upside 14.35. Then after solving, you will get 5.55 gram calcium chloride. This is the amount of calcium chloride. Hence, correct option is A, first option, 5.55 gram. Next question I am reading. The weight of select lime necessary to decompose completely 1.07 gram of ammonium chloride is first option 0.74 gram, second 1.48 gram, third 7.4 gram, fourth 0.37 gram. Again one more time I am reading the question. The weight of select lime necessary to decompose completely 1.07 gram of ammonium chloride is first option 0.74 gram, second option 1.48 gram, third 7.4 gram, fourth 0.37 gram. Just to think, this question also you can solve it. This is also based on reaction. All numericals what I am discussing now, that is based on chemical equation. Hence you have to write the reaction. Only you can solve the numericals. Then here is just to write the you can say reaction. Then easily you can solve it. Okay, just to think which reaction is suitable. Here, now I am giving you hint. 2NH4Cl plus calcium hydroxide, that is a slacked lime. Okay. Then reaction you have to write ammonium chloride plus calcium hydroxide. It will give calcium chloride plus 2NH3 plus 2H2O. This is the balanced reaction. 2NH4Cl plus CaOH whole 2, it will give CaCl2 plus 2NH3 plus 2H2O. Means 2NH4Cl will completely decompose the calcium hydroxide. Then NH4Cl molecular mass, easily you can calculate. Ammonium chloride molecular mass is 53.5. How will you get? Easily you can calculate. Nitrogen is 14 plus 4 hydrogen. Then plus 4 plus 35.5 NH4Cl. Then you will get 53.5. Then in balanced equation 2 NH4Cl required. Means 2 into 53.5 gram. This will completely it will react with 74 gram calcium hydroxide. Its molecular weight is calcium hydroxide molecular weight is 74. Easily you can calculate. Calcium is equal to 40 and OH, O means 16, H is 1, 17 and whole 2 is there means 34. Then 40 plus 34, 74. Then here 2NH4Cl means 2 into 53.5 gram, that is 107 gram. Then for complete you can say decomposition of 74 gram calcium hydroxide, you require 107 gram ammonium chloride. Correct? Now easily you can calculate. That is the basis. This equation is the basis. Then 1.07 gram ammonium chloride. How much it will be required, you can calculate. Okay. Here in question, it is the weight of select lime necessary to decompose completely 1.07 gram ammonium chloride. Then 74 gram calcium hydroxide is completely decomposed by 107 gram ammonium chloride. Correct? Then for 1.07 gram ammonium chloride, how much calcium hydroxide is required? Easily can calculate. 74 gram is required for 107 gram ammonium chloride. Then for 1.07 gram ammonium chloride. Correct? 74 gram calcium hydroxide requires 107 gram ammonium chloride. Then for 1 gram, how much? And then for 1.07 gram, you will get, on solving, you will get 0.74 gram calcium hydroxide. Okay. Then its correct answer is first option, 0.74 gram. Okay. You actually wanted to calculate weight of calcium hydroxide. Okay. For 1.07 gram ammonium chloride. Then 74 gram calcium hydroxide is required for 107 gram ammonium chloride. Then for 1 gram. And then for 1.07 gram. You will get, after solving, you will get 0.74 gram calcium hydroxide. Okay, this is the correct answer, 0.74 gram. Option A is correct. Now, one more question I want to discuss. A mixture of NaI and NaCl on reaction with H2SO4 gave Na2SO4 equal to the weight of original mixture taken. The percentage of NaI in the mixture is, first option 82.38, second option 26.38, third option 62.38, fourth option 28.38. Again, one more time, question I am reading. A mixture of NaI and NaCl on reaction with H2SO4 gave Na2SO4 equal to the weight of original mixture taken. The percentage of NaI in the mixture is, first option 82.38, second 26.38, third 62.38, fourth 28.38. Just to calculate, first to write the reaction, only then you can solve it. Otherwise, you can't solve it. Here, now I am giving you hint how we will solve it. Suppose weight of original mixture is 1 gram and NaI present in that mixture is x gram. Original mixture, suppose weight of the original mixture is 1 gram, suppose, and NaI present, that is equal to x gram. Then what is the NaCl in the mixture? 1 minus x. Correct? Suppose a total weight of the mixture was 1 gram and NaI present is x gram. Then what will be the NaCl? 1 minus x gram. This is the first step. Then now after that reaction you have to write 2 NaI plus H2SO4. You will get Na2SO4 plus 2HI. Then what is the molecular mass of 2 means NaI? The Na is equal to 23. I is equal to 127. Correct? It will become 150. 150. Then 2 molecule is there. 2 NaI means 2 into 150, 300 gram. Then now Na2SO4 you are getting. What its molecular weight? Usually you can calculate Na2SO4. Then 23 into 2, 46. Sulfur is 32. Oxygen is O4 means 64. Add all, you will get 142. Means 3 gram NaI. From 3 gram NaI you will get 142 gram sodium sulfate. Okay, 300 gram sodium iodide NaI gives 142 gram sodium sulfate. Then 1 gram, how much it will give? 1 gram, 300 gram NaI gives 142 gram sulfate, 142 gram sodium sulfate. Then for 1 gram, then for x gram, then for the x gram you will get 142 divided by 300 into x gram. That is the amount of sodium sulfate. Correct? After solving, you will get 0.47x. Leave it x like that. 142 divided by 300. You will get 0.47. And x was there into x. Write only simply write 0.47 x gram. You have to find out the value of separate you can x value you can find out and the end. Then this you got x gram NaI you will get from 0.47 x gram sodium sulfate. Now another reaction. 2NaCl plus H2SO4. Again you will get Na2SO4 plus 2HCl. You have to write the two reactions. First reaction between NaI plus H2SO4. Already I told you. Now second reaction NaCl plus H2SO4. Because in the mixture both were present and both can react with H2SO4. Hence two reaction is required. Then now second reaction you can write 2NaCl plus H2SO4. You will get Na2SO4 plus 2HCl. In both reaction you are getting sodium sulfate, you remember. Okay. Then now again NaCl, you know, NaCl molecular mass is 58.5. How? Then Na23 plus chlorine 35.5. Add, you will get 58.5. Then 2 into 58.5 means 117 gram. Then 117 gram NaCl. You will get, that will give you 142 gram Na2SO4. Its molecular mass is 142 Na2SO4. Then 117 gram sodium chloride gives 142 gram sodium sulfate. Then easily you can calculate 117 gram sodium chloride gives 142 grams sodium sulfate, then 1. And then for 1 minus x. 1 minus x. Amount of NaCl in the beginning you have calculated 1 minus x. Correct? And x is the amount of NaI. Then only on this basis you can calculate 117 gram NaCl gives 142 gram Na2SO4. Then for 1 minus x gram NaCl. You can calculate. You will get 142 divided by 117 into 1 minus x. Correct? Then after solving you will get 142 divided by 117, 1.21 into 1 minus x gram. You have multiplied with 1 minus x, that you leave it like this. 1.21 1 minus x gram. Then see total sodium sulfate. Now you have seen that for x gram NaI you calculated, that was the 0.47 into x gram, and now you got 1.21 into 1 minus x gram. If you add both, you will get total sodium sulfate. Correct? Then now here, after that what you will do, 0.47 x gram plus 1.21 inside bracket 1 minus x is there, then you can write 1.21 minus, means 1.21 is common, then you can write that 1.21 minus 1.21 x. Correct? Then total weight will be what? Means both weight is 0.47 x, 0.47 x gram plus 1.21 into 1 minus x gram. Both is equal to 1 gram. In the beginning, you have calculated. Correct? In the mixture that you calculated 1, weight of the original mixture was 1. Then here, weight of NaI and weight of this NaCl, both you have calculated. Then both should be equal to 1. Then after that, x value can calculate, because now 0.47 x plus 1.21 plus 1.21 x, that is equal to 1. Actually 1.21, 1 minus x was there. That bracket you have removed because 1.21 was common. That's why you have written 1.21 plus not, it will be not plus, minus will be there. 1.21 minus 1.21 x. Correct? They add all, that is equal to 1. Then you will get 0.74 x is equal to 0.21. 0.74 x is equal to 0.21. Then x value easily you can get 0.21 divided by 0.74. X value will get 0.2838. 0.2838. In percentage, it will become 28.38%. Because it is in 1 gram, then for 100 gram in percentage, it will be 28.38%. Correct? Then now its correct answer will be x value calculated 28.38%. Okay, then its correct answer will be what? 28.38%. Then option D is correct. Option D is correct. 28.38. Okay. Now I am stopping only here. Next class again I will continue. Thank you.